I see, I remember you, if you remember me.
Hello friends, welcome to 7-minute study. In this video I'm going to talk about LCM and HCF, that is least common multiple and highest common factor. I'm going to talk what is LCM and what is HCF, and then I'm going to explain some basic properties using which I'm going to solve a few small problems. These examples are going to be helpful for you to solve number systems related problems which you face in the aptitude exams, like competitive exams or any other interview based exams. So let's start with it. What are multiples exactly? A multiple is any number which is exactly divisible by another given number. Like if 3 or 6 are multiples of 3. Okay. And a factor is nothing but a number which divides another number, leaving some remainder or no remainder. Leaving no remainder. That is zero. When we get zero remainder by dividing another number, that number is said to be a factor of the given number. Let's say we have 24. So we factors of 24 can be 2, 3, 4, 6 and 12. 1 is also a factor of 24. So what's an LCM basically? That is least common multiple. As we have seen, what's a multiple? Least common multiple is nothing but if we have two given numbers, then among the multiples of those, the common multiple which is the least is said to be the least common multiple, as the name suggests. Let's say for example 10 between 10 and 15 and 20, LCM is 60. LCM is nothing but the common multiple which is possible for all the numbers. Here it is 60. Let's say let's consider 10 and 15 only. If we consider 10 and 15, the factors of 10 would be the multiples. So the factors of 10 would be 5 and 2, and the factors of 15 would be 5 and 3. So what would be the least common multiple of 10 and 15? It would be nothing but 5, 3 and 2. That is, a product of 5, 3 and 2 is nothing but 30. So the LCM of 15 and 10 is nothing but 30. Okay, that's how we find out LCM. And a highest common factor can be is nothing but the greatest factor that is available to divide any of the two or more given natural numbers. Okay, it is also known as GCD, or the greatest common divisor. For example, HCF of 4 and 6 and 4, 6 and 2, 8 is 2. It is it can be evident from the given example. 4, 6 and 2, the factors are like this. So the HCF would be this. What would be LCM? 4, 6 and 8, right? 2 into 2, 3 into 2, 4 into 2. The least common multiple out of all these three, what is the least? This is nothing but 2 into 2 into 2. Okay. Okay, what would be the least common? 2's highest power is 2 power 3 and 3's highest power is 3. So 2 power 3 is 8 into 3 is 24. So this is the LCM of 2, 4, 6 and 8. This is how we find LCM, and this is how we find HCF. Now let's go through some properties of HCF and LCM. The property 1 describes that the product of LCM and HCF is nothing but the product of two given natural numbers or any natural numbers. That is, LCM and into HCF is equals to product of the numbers given. So let's consider an example of taking HCF and LCM of 9 and 12 and then verifying it or cross-checking it with the product of those numbers. So let's now find out the LCM and HCF of 9 and 12, which is done like this. The factors of 9 are 3 square, that is 3 and 3. The factors of 12 are 2 square into 3, or nothing but 2 into 2 into 3. So the LCM and HCF of 9 and 12 can be found out like 36 and 3 respectively. So the product would be 36 into 3, which is 108. And we can even observe that the product of the given numbers, that is 9 and 12, is nothing but 108. So this is how we can prove the first property of HCF and LCM. So what is the second property of HCF and LCM? HCF of a co-prime numbers is 1. Therefore, LCM of the co-prime numbers is equal to the product of the numbers. This is nothing but derived from the above property, which defines that LCM into HCF equals to product of any two numbers. If HCF of the cofactors is 1, then it would be nothing. It would mean nothing but the LCM would be the same as the product of numbers, right? Because HCF is already 1. You can see from the example, like let's say we have 8 and 9 are two co-prime numbers. Using these numbers, using these numbers, we verify that the above property is true or not. First, we find out LCM and HCF of 8 and 9, which would give us 72 and 1. Okay, the co-prime, that is the only HCF possible between 8 and 9 is 1. So the product of 8 and 9 would be 72, and the LCM of 8 and 9 is also 72. So we can verify that 72 into 1 equals to 72, right? So the second property, where the HCF of co-prime numbers is 1 and the LCM would be the product of these numbers, is proved. Let's go to the property 3, which defines that LCM and HCF of fractions. This is very important, friends. Please note it down. This would be helpful to solve few problems related to ratios and proportions and also number systems. So what's LCM of fractions? LCM of fraction is nothing but LCM of numerators divided by LCM of denominators. And similarly, HCF of fractions is equals to HCF of numerator divided by HCF of denominators. So that sorry, it's actually wrong. LCM of fractions is LCM of numerator divided by HCF of denominators, and HCF of fraction is HCF of numerator divided by LCM of denominator. It is nothing but, if we have asked to find out LCM of a fraction, then we have to first find the LCM of numerator and then the HCF of denominator. Similarly, if we are asked to find out the HCF of fraction, then we have to find the HCF of a denominator and then we have to go with the LCM of denominators. Let's consider an example to understand it well. So let's say we have to find the HCF of 12 by 25, 9 by 10, 18 by 35 and 21 by 40. So first, to find the HCF, we have to find the HCF of numerators and then we have to find the LCM of denominators and then we have to divide it. That's the HCF required. So let's go with a few examples to understand it well. This will be placed in the next video. Thanks for watching the video. Please subscribe to stay updated.